Hi everyone, this is our another lecture on data labeling. Okay, so uh, we have machine learning, we know, and then data labeling or data annotation. So uh, mm, we previously covered data labeling by human and what are the issues and how to do. And today we'll discuss about automated data labeling strategies that are evolving in the world by researchers, and uh, they are exploring different types. We can see like Tesla, Dell E, Labelbox, Snorkel, mm, uh, and others. Okay. Now, level data, just to recap very quickly, that normally data are not labeled, they are raw data. So when we have data, we assign any specific categories or tags or labels, then it becomes a level data. That means we know what is it, what is not. So for example, if you have MRI image and you are not a doctor, you look at these things and you don't understand what is it. Oh my God, I don't know. Then you go to a doctor and then you find that, okay, there is a tumor and so on. Okay, so that's the point. So for example, my son had an MRI in 2023, April 29th, in a hospital. And till now, we did not get the doctor. So we don't know what is going on in his MRI report. Okay. They gave us just a few sentences, and using Google search, the writings are horrible, but we did not get the, professionals yet. So we can say that I collected the MRI data from the hospital, and after paying a little bit, but as a normal person, I don't know what is it. So to me, that CD and inside the MRI data is unlabeled raw data. So I don't know. Now, when expert will label it, then it becomes a level data. We know that this is the tumor, or this is bad, this is good, and so on. So, all right. So, like email, I hope that my son is okay, even though 1.5 years, no doctor. So, email with spam or not spam, this is one category. Customer feedback leveled is as positive, neutral, or negative. So this is another category. Movie reviews like star, 5 star, 4 star, or WAC. So it depends on, like, different people will have different choices. For example, my lecture will be appreciated by few people. Few people will say, "Oh my God, it's a very poor lecture," and they stop from here. So it depends, because nobody can please everybody on earth. But more or less, we have reviews, and these reviews are from human being. Whether it's good or bad, we don't know. But these are tagging or categories or levels, and based on these, the AI is learning. So if AI is learning based on poor data, its learning will be poor, and vice versa. Of course, if it can gain the capability like human being to learning from the bad background, we can be a better one, and vice versa. So AI will be like this, hopefully, or not, I don't know. Now, this is one example. I repeat it even in the last lecture, that can human or AI automatically understand this kind of, different countries rules and regulations, or this symbol, like this is a stop symbol in Japan. If we don't train AI or even human being and level the data for training, how to know? So for me, if I go to Japan and say my Japanese friend or my friend who is living there, or instructor, a driving instructor, told me that, I think that symbol, it means stop. Sometimes on the floor it says stops on the road, so it means that you stop. So this is training for me. It means that the person is giving the label data to me. So, and when I see it, my brain can connect it. Of course, we forget. So that means the learning was not enough. So if we see more and more and more, it becomes very natural, and our training is well done, something like this. Now, we notice that human annotations are extremely challenging, especially for typically large amount of data which is needed in AI. Like it's repetitive and boring, time consuming, error prone, and expensive. If you forgot, look at the previous lecture. Okay, So where we covered this kind of, issues in details, that how much challenging human annotations can be. That's why we are looking for automated labeling. Now let's see the a few basic steps of automated data labeling. All right. So initial human labeling is needed. A small subset of data is manually labeled. Don't ask me that what is a small subset. It is 10%, 20%. It depends. Okay. It depends on the next method and others, and varies from one company, one data set to another. There is no specific number. So a small subset of the data is manually labeled to provide a foundation for the machine learning model. Today, I don't know, maybe once upon a time, there will be something, and then, yeah. So model training is another point. The label data is used to train an ML model to recognize patterns and assign labels to new unlabeled data. So it means that my training, say, is based on a small, a subset of data manually labeled by human being, and then we train the AI model, and automated labeling, the trained model automatically labels the remaining data, focusing on high confidence prediction. Of course, when AI will do automatically, who will ensure that this is good labeling or bad labeling? So we need human review and feedback, just like large language models like ChatGPT and Llama, Claude, and others. Okay, so when you use them, we have the option to say good, or we have the option to say bad. So, and give some even written feedback. So if we do, then these kind of things are, supporting the AI model to be better and better. So human review and feedback. So human levelers review a sample of automatically, not all, a sample of automatically leveled data to identify errors and inconsistencies. These kind of things are feedback based, and the model is refined based on this, and this way things are improved. It's not easy, by the way, and then we'll see how. So how to label data, automated data labeling. So there are a few strategies, like for example, semi-automated labeling, or self-automated labeling, or active learning, weak annotations, and so on. So, but we'll mainly focus on active learning, but we just cover a few points about this. That semi-automated labeling, using a basic algorithm to pre-label images as day or night, and then having humans verify and correct the labels. Automatically categorizing news articles by keywords, another example, or then editors define the categories. So you can say this is semi-automated labeling. Using speech recognition to create initial transcripts of interviews, then human experts will read it and listen it and correct any errors. So this way, we train. Another one is semi-supervised learning. Okay, so it uses a small amount of level data to help level of a larger set of unlabeled data, just we said before, often combined with neural networks and clustering techniques. Self-supervised learning, levels are inferred from the data itself through tasks like predicting missing parts, whether there is any, for example, solving jigsaw-like puzzles within the data. So these kind of things are done in NLP and image analysis. Now we focus mainly on active learning. Okay, it's a machine learning model that identifies uncertain cases in a set of product reviews, and say ask human annotators to label only these difficult examples. For example, an image classification system requests human input only for animal species it's unsure about it. So the AI or active learning model is annotating, and it's saying that some animals I don't know, or their weight is low, like I'm not strong to make a decision, so can you help me? And through this manner it gradually improves its accuracy. Now from OpenAI, let's see how they explain the flow diagram of of active learning. All right, so according to OpenAI, they say that you can read from this website in details, but number one step is that Start by leveling a few hundred images, say current level data set. So start with a small data set of labeled images, then train a classifier on these data. So number three is active learning algorithm, then uses the current classifier to select a handful of unlabeled. So we have unlabeled images, so we give them, and then it checks to improve the classifier performance. And finally, I mean, human labelers, look at those things and iteratively improve the things. So human levelers help, and then new level data, and through this, a nice cycle, they are learning. So this is called active learning. All right. Another example from Amazon Web Services, AWS. So you can also have a look here that first ML model for leveling data is trained on a subset of your raw data that has been leveled by humans. So the raw data, human helps to level partially a subset of it. Active learning model is trained from human level data. Okay. Then where the leveling model has high confidence in its result based on what it has learned so far, it will automatically apply levels to the raw data. Where the leveling model has lower confidence, means the weight is low, it will pass the data to humans to do the things. So if active learning model or AI model can feel that this is highly confident about it, then just go on. But if they feel that the lower confidence, so the weight is low, okay, suspicions and so on, it depends on the algorithm itself. Then the active learning algorithm will send the data to humans to do the leveling, and human will check. So ambiguous data is sent to human levelers for annotation. Okay, our task is to check and make it better. So the human generated levels are then provided back to the leveling model for it to learn from and improve its ability to automatically level the next set of raw data, because the training is going on and on, and with time we can say that the model can learn more and more data automatically and substantially speed up the creation of training data set. So you have a raw data, part of the raw data or subset of the raw data is leveled by human being, okay, and then active learning model is trained from human level data, and when there are other data, they check that whether the other data, the model understand its level automatically. Ambiguous data is sent to the human levelers for annotation. Human level data is then sent back to retrain and improve the machine learning model, and so on. So this is Labelbox, another company. They do active learning based, supports. You can have a look how they do, and they also mention this kind of, examples. So we have shown from OpenAI how the active learning is done, AWS and Labelbox. If you want, you can just have a look in details. So add newly labeled image to the training data, train model based on available data. So this is the starting query that, what are the next samples, and level or re-level the selected samples, and so on. So these kind of circles are going on and so on. Now, who are the big companies actively doing active learning? Because it's impossible to make abnormally enormous amount of data annotations by human being. All right. Now say Tesla, they employ active learning for their autonomous driving. Okay. So you see that, if you watch this YouTube lecture from Tesla AI Day 2022, what they say exactly, that in academia at some point, the speaker said, in academia we often see that people keep data constant, which is true, because my data set is fixed. If I want to make more data, I need more people, more data collections, and more annotations, and so on. So now Tesla, it's very much the opposite. Okay, we see time and again that data is one of the best, if not the most deterministic levelers to solving things, so challenging cases. So that's why they do opposite. What they do, they use effective active learning to select data points, reducing human leveling, focusing on critical data. So these are the points they mention. I'm not going into details. If you are interested, you can just read how they do. But the basic point is Tesla is doing active learning for their autonomous driving. So definitely they train the model with some, level data by human beings, and later on their active learning model are developing more data and self-learning. Dell E2 is another example. They utilized two different active learning techniques to iterate on the image classifiers to find and fix false positives and to find and fix false negatives. Intel, this is another example. They use weak supervision. Okay, so Intel's weak supervision with Snorkel for NLP. So Intel employs weak supervision with Snorkel. This is a company to efficiently level large amount of data set for natural language processing tasks. It's not easy, but they are working on and they have developed. So there are different ways. Definitely in this basic lecture we cannot cover what is the meaning of weak supervision or details of others, because we are not going into the methods. So the Intel's weak supervision, if you want, you can check. Now, what about the maturity of the automated data leveling? Definitely, we understand that it's started like a few years and it's not matured yet. It will take much more time. Need more efforts from good scientists and thinkers to develop new methods like weak supervision, active learning, or self-learning concepts, and so on. Okay, so that we can use them for different applications. But it's not easy, especially complex tasks, or nuanced data like medical images, MRI, CT scan, and others, or small sample sizes, and so on, then what to do. Okay, future challenges in this domain. Definitely explainability is important point, making that automated leveling, what they are doing, they are interpreting for quality assurance. Data variety in broadening methods to adapt to diverse data types beyond text and images, like for example sensor data, like so you see that all the wearable sensors, smartwatches, millions of people are using all over the world from very different companies, and they are collecting our data seamlessly. But how to annotate them, that which time I was walking or running or under stress or happy or sitting and so on. So all right, and another point is that can we do real time leveling, okay, especially in video streaming cases and so on. Now, how to maintain quality? Because we talk sometimes about buffet. If you go to a buffet restaurant and you find that 100 different kinds of foods, even 3-4 kinds of onions are considered different kinds of salads and so on. But basically, we say that 30-40 kinds of different dishes. But what about the quality of the food versus you go to a specific restaurant and just get Hyderabadi biryani, or excellent kebab shops, excellent Turkish shop, and then you just get the kebabs, wow, mouth watering food and so on. But how to maintain the quality of the data? So that's why it's very important, and active learning is has a huge challenge to maintain the quality, because if human is involved, even if we make mistakes, we have biasness, but still we can do better. Okay, so far. So data validation, regularly review label data to ensure accuracy and consistency. Inter annotator agreement. You remember the lecture previously we mentioned about the human walking pattern gait. Okay, the previous lecture you can click, you can see that gait, and we have gait, annotators uncertainty. Like say for example, I am the annotator number one, and she is another annotator number two, and I said something and she said in a different way. Okay, now this is universal, that people cannot agree on every point. Okay, so annotators understanding of something may vary, and based on this, the annotation or ground truth or tagging will be different, might be different. So inter annotator agreement is important. So check if different levelers are assigning the same levels to the same data points. Okay, and how to avoid model bias. These are also extremely important. So for this point, you may look into AWS website for this. Now, let me summarize the level data versus unlabeled data under different perspectives, because in the previous two lectures we discussed about level data and unlabeled data, how to make human annotated data, what are the different things, and how to plan for automated data annotations or labeling in this lecture. So to conclude, before I conclude, the point is that level data means data that has been tagged with one or more levels or tag or classifications or classes or patterns identifying certain characteristics or classifications. In unlabeled data case, it's a raw data, it's unprocessed data. In machine learning, it's primarily used in supervised learning. So I mentioned before that some people consider that artificial intelligence is machine learning. Actually, machine learning is a subset of AI, even though most of the modern AI stuffs are based on machine learning, but AI is not exactly as machine learning. The next point is that many cases, I gave example even from AWS writing, that they mention that machine learning, and almost like supervised learning, but it's not exactly the same. Supervised learning is the most contributing machine learning methods, okay, or type, but there are other methods like semi-supervised, reinforcement learning, unsupervised learning, and so on. So this level data is must for supervised learning. That's the point, okay? Preparations. We require human efforts or automated process to assign levels. How human efforts are needed, we can look at the previous lectures and automated process here. Cost, of course, we understand that human efforts we need, it's expensive and time consuming, but if we can have automated processing, then it would be faster and easier and cheaper, but trustworthiness should be ensured. Learning approach. Level data is used to train models to map inputs to unknown to known outputs. Like we try to match like spam or non-spam, or happy, neutral, or unhappy, for example. Okay, or the image has tumor or no tumor, or so on. But unlabeled data can be used to discover hidden patterns or structures in data, like clustering and so on. All right. So accuracy, we can definitely achieve higher accuracy for a specific classification task because our training is based on level data. If the training is good, AI model will usually develop and produce higher accuracy or better results. Applications for level data, classification, regression, and prediction are mainly based on supervised learning. And the challenges are they are time consuming and expensive, and most importantly, the potential to have human bias in leveling. Okay, especially if the leveling data belongs to human being, race and culture, religion, region, and so on, because the world is unfortunately split into so many biased things. Unfortunately, we are not one world, one human being. We are demonstrating many different things. So when people do like this way and annotate data where they can identify human personality or locations and others, then biasness automatically comes to many people, and so on. Unfortunately, it is a very bad problem for the global world, and we must stop it and be a better person and to make a better world. Now, these are the different things we saw so far. Summary: leveling is extremely important, huge scopes for research, and huge scopes to contribute to develop new strategies, and even for business, like can you use different kinds of AI models to in a focused area to help better data annotations purposes where there are not much development. Okay, so you can read and study and go through and even make money. Combine techniques using a blend of semi-supervised, active learning, and weak supervision can maximize efficiency. Iterate with human feedback. I mentioned before that continuous retraining with human validated data is needed to reduce the error and the gaps. So human feedback is extremely important for data annotation. Of course, uncertainty among annotators, evaluate uncertainty. These are also important. Okay, and tool selection. What kind of evaluation tools will you use? So here I mentioned only Labelbox and Snorkel that Intel use, Prodigy based on data type and leveling needs. There are a few others you can check and explore. With that, thanks a lot. Let's do the best, not just better, okay? And together we can build a better world and so on. So study hard and do the best thing you can do. All right. So thank you. So with that, I would like to conclude the presentation today. You are feel free to give any comments so that if you have anything, and if I know the answers, I'll try to find. Okay. Thank you very much.